Good morning, everyone. Video number 2 today.
All right, Intro to Calc 5.2 Part 1, Basic Differentiation Rules. And the reason why I have a smiley face, and I'm kind of happy I'm not teaching this in class, because all of that hard work and long work that we did with the limits, we're not going to do it anymore. I'm going to show you some shortcuts. All right, so our first rule, okay, it's called the constant rule. And what that is going to tell us is if we have a function, f of x, it's equal to a real number, such as 5, 7, negative 10, whatever, then f prime of x is always going to be 0. All the time, no matter what. And the reason for that is if we have the graph, and this equation, not that great of a graph, but let's say this is the line y equals 3. If I give you an equation, y equals 3, and I ask you to graph it, it's going to be a horizontal line. Derivative is just slope. And what is the slope of any horizontal line? It's always 0. That's why it's called the constant rule. No matter what you're taking the derivative of, if it's a constant equation, this derivative is always 0. That one's really easy. The second one is called the power rule. And this one would have been super beneficial probably a couple, like last week. So if we have f of x is a function, let me start over. Okay, if n is a rational number, so remember, rational numbers is any number that can be written as a fraction. Then the function f of x is equal to x to the power of n. Then, remember d dx, I said at the very beginning when we started talking about derivatives, is just another way to say f prime of x, the derivative of x, of the function x to the power of n. All we're going to do is we're going to take our exponent, kick it out in front, and then we're going to subtract 1 from the exponent. And this might look kind of hard because we just got a lot of letters going on. So let's do some examples. So I guess I'm going to box this. This is our first rule that you're going to want to know and memorize. So if I give you the function, let's call this a, y is equal to x to the power of 4. If we're taking the derivative of this, y prime, we're going to take this 4, kick it out in front, and then we're going to subtract 1 from 4 to get 3. And that's it. That's our answer. Way quicker than finding the limit of f of x plus h minus f of x all over h as the limit approaches, h approaches 0. So, like I said, glad I'm coming at you at a computer screen and not in class because I could only imagine the looks you'd be giving me. So, let's try another example. B, very important when we do these, is to make sure we have exponents. So f of x is equal to the 4th root of x. So for this one, we technically don't have an exponent, but we know we can change it from radical form to exponential form. This is the same thing as saying x to the 1/4. Now that we have a rational exponent, a number that can be written as a fraction, we can do this rule. So we're going to have f prime of x equal to, take the exponent, kick it out in front, 1/4 x. When we subtract 1 from 1/4 minus 4/4, we get negative 3/4. And just remember, it's mathematically, like grammar, incorrect if we leave negative exponents. So we have to move it to the denominator, the x to the denominator to make it positive. And there you go. Again, way easier than the limit method. And the last example is C. We have g of x is equal to 1 over x to the power of 3. Again, when we do this rule, we have to make sure we are dealing with just numerators. So we're going to change this to x to the negative 3. Now that it's a rational exponent, I'm going to follow the power rule. So g prime of x. I'm going to kick this out in front, so it's negative 3x. I'm going to subtract 1 from negative 3 to make it negative 4. But again, remember, we can never leave negative exponents. So our answer is negative 3 over x to the power of 4. Perfect. So power rule is a nice quick way to help us get those derivatives. Another example with power rule, example 2. We're going to find the slope of the tangent line and don't worry, I'll always post a copy of my notes to Google Classroom after. The slope of the tangent line of, let's say, f of x is equal to x to the power of 5 when we're going to do 2 examples here. Our first one when x is equal to negative 1, and our second one when x is equal to 2. So remember, when we're finding the slope of the tangent line, slope is the same thing as the derivative. So the first step is to find f prime of x. Before, it would take a long time. We can quickly identify now that f prime of x, using the power rule, take the 5, kick it out in front, subtract 1 from 5 to get 4. So now this is the general equation for slope. Now if we're going to find it at these specific points of x values, when we plug step 2, plug in the x value. Okay, so when we plug the negative 1 in for x, 5 times negative 1 to the power of 4, the slope for this example is going to be 5. And then for part B, when we plug it in, the slope is going to be equal to 5 times 2 to the 4th, 2 to the 4th, 2 times 2 is 4, 8, 16, and then 16 times 5 is 80. So again, we're doing the same types of problems as before. We're just able to do it much quicker because we have this shortcut. So another example that we did last week, I'm going to call this one example 3. We are going to find the equation of the tangent line f of x is equal to x to the 3 at x is equal to negative 3. So your first step here is to find the point on the original graph. So when we plug in negative 3 into our original f of x function, we're going to come up with the point negative 3, negative 27, right? Because negative 3 times negative 3 times negative 3, negative 27. So again, when you're, writing the equation of a tangent line, find the point. Second thing, find the derivative. So we can quickly find f prime of x to be equal to 3x squared, because I'm going to take the 3, kick it out in front, subtract 1 from it. Step 3, find the slope. So in order to find the slope, we're finding the slope at x is equal to negative 3. We're going to plug negative 3 into the equation for the derivative. 3 times negative 3 squared. And you're going to get a positive 27 this time. So that is the slope. And remember step 4, write the equation. So when we write the final equation, I'm going to do it in point slope form. So y plus 27 is equal to 27x plus 3. And then you can change that from point slope form to slope intercept form if you're interested. Y is equal to 27x plus 54. Again, way less work and way more time efficient than finding the limit. The next rule, it's the constant multiple rule. Okay, so if we have c times a function f of x, if we're going to do the derivative of c f of x, what we're going to do is just take that constant and continue to multiply it to the derivative of f of x. Okay, very similar to the rule that we just talked about, the power rule. I'm going to box this, important to know. And let's try some examples. Example number 4. Okay, our first example, y is equal to 3 over x. Again, our first thing is to make it a x to the power. We're going to make sure that there's no denominators. So we have 3x to the power of -1. Now I'm going to use the power rule. I'm going to multiply this -1 out in front. So 3 times -1 is -3. When we subtract 1 from 1, we get -2. But then again, we have to make sure that our exponent is positive. So y prime, oh, that's what this arrow is -3 over x squared. That's y prime. All right, let's try a couple more. B, we're going to say s of t is equal to 3/4 t squared. So when we find s prime of t, we're going to take this 2, multiply it out in front. 2 times 3 over 4 is 6 over 4. When I subtract 1 from 2, we get 1. And then I'm just going to simplify. 6 over 4 is 3 over 2. And technically, we don't need the 1 there, so 3 over 2t. Good. Okay. Part C, we're going to do g of x is equal to 3 times the cubed root of x. Again, we have to first change this radical to an exponent. So we have 3x to the power of 1/3. So now when we try to find g prime of x, take this exponent, kick it out in front. So 3 times 1/3 is 1x. And when we subtract 1 from 1/3, we get -2/3. But again, can never have a negative exponent. So 1 over x to the 2/3. Oopsies. There we go. Again, one more because it gets a little bit complicated, but we're doing the same idea. I'm going to say y is equal to 1 over 2 4th roots of x to the power of 3. Again, I'm first going to change this to a rational exponent. So 1 over 2 x to the 3/4. And then again, I'm going to make it so my exponent, there's no fractions in the function other than a constant, x to the -3/4. Now I'm going to do the power rule. Take this out in front. You're going to get -3 over 8. When I subtract 1 from -3/4, you get -7/4. Again, make it positive. We have -3 over 8. Since the x was in the numerator, I'm going to drop it down to be in the denominator and becomes 7 over 4. Again, we're doing lots of the same ideas with the power rule. And the very last rule that we're going to talk about today is the sum and difference rules. Okay, sum and difference rules. So we're going to have the derivative of dx. If you have two functions and you're adding them together, the derivative of that is just each of them doing it separately. And again, we're still adding. And the same thing with subtracting. So the derivative of d of x of two functions that you're subtracting, you're going to take the derivative of each of them separately. Oops, but this time you're going to subtract them. Cool. So again, two major ideas to keep in mind. So our last example, example 5, there are only 2 examples for these. So our first one A, we're going to say f of x is equal to x to the power of 3 plus 5x squared plus 6. So when we do the derivative for this, f prime of x, because we're adding this function plus this function plus this function, you're going to do the derivative of each of them separately. Using the power rule, so I'm going to take the 3, kick it out in front, 3x, and then 3 minus 1 is 2. I'm going to continue to add this. I'm going to take this 2 and multiply it out in front, so 5 times 2 is 10. And then 2 minus 1 is 1, and technically you don't write it. And using the derivative of our very first one, our very first rule, the constant rule, the derivative of any constant is plus is 0. So you can have that plus 0 there, or you don't. Either way, I will take it as a correct answer. Cool. And our last one, B. If I say g of x is equal to negative x to the third over 6 plus 2x squared minus 6x, we are going to find the derivative of that. The power rule, this is okay. It's okay if there's a fraction here because it's not the variable in the denominator. It's just the a constant of negative 1/6. I'm going to multiply the 3 out in front to get negative 3 over 6 x squared because 3 minus 1 is 2. I'm going to take this 2 and kick it out in front plus 4 x to the power of 1. And technically there's an invisible 1 here, so I'm going to multiply this 1 out in front, so it's still going to be negative 6. And when I subtract 1 from the exponent this time, you're going to be left with x to the power of 0. And remember, anything to the power of 0 is 1. So here is your final answer. But remember to always simplify. I would take that as an answer, a better answer. G prime of x is equal to negative 1/2 x squared plus 4x minus 6. Awesome job, guys. Made it day 2. Bye.